This is a servo. It's a motor that can be instructed to move to a particular position, and in this video we find out how we can connect it to the Uno and control it with our joystick. Pushing wires directly into the connectors of the servo and then the Uno is a rapid way of setting up the hardware. Servos only have 3 connections. The black, or in this case brown wire, is connected to ground, and the red to +5. The orange, or here yellow wire, should be inserted into pin 9. Everything else remains the same as the previous video. Here we're going to use the joystick to control the position of the servo. So open a blank sketch. Enter starting comments and setup and loop areas as before. In this sketch I'm going to be a little more precise in my coding practice and provide you with a template to follow for the future. Integer is a lovely word, and all that it means, as we discovered in the previous video, is a whole number like 5, 7, 51, 2006. 5.6, 8.2 and 5.5 are not whole numbers and therefore can't be integers. Something that remains the same is constant. It never changes. Something that does change is a variable. It varies. And we use constants and variables in programs. We need to tell the Uno when we write a sketch what to expect by way of the numbers and the names that we're going to use, and whether these are integers or variables or not. Geeks call this declaring. So here is the real world, here is the breadboard, and here is the schematic diagram of the hardware we should have in place. As we don't reconnect pins once the program is running, they can be considered to be constant, so let's state this in the sketch. They're obviously integer, as you obviously can't have pin number 2.5. So constant int button equals 2, button input for joystick, constant LED equals 13, onboard LED. Tell the Uno what to expect and prime the variables with some kind of initial number. A number to start with that's reasonable. Int x equals 512, int y equals 512, int z equals 0. Remember the coding secret from the last video? Don't reinvent the wheel. Well, the good news is some clever codes have already written software to drive a servo. All the work has been done for us already. We can include all of their work in our sketch in just one line. It's here, include server.h. Including this line gives us the ability to command the servo. Try compiling a copy without this line. The servo is known as an object, and in case we're going to use more than one servo in the future, let's make what is known as an instance of the first servo, and call it something helpful. Servo, first_server. So we need to tell the Uno where the server is, and this is done in the setup. Thus, first_server.attach. Obviously, if we have more servos, we could put these in the setup too. Servers are a little different to ordinary motors in that they just move to a position and remain still until the next command. This servo works by sending it a value between 0 and 180 to position its arm between 0 degrees and 180 degrees. Setup complete, we can now move to the loop. All we need to do is to read the joystick and send the value to the servo. Wait a little time for the system to settle down and go around the loop again. The command to position the servo here is first_servo right, then position in degrees. The loop for this then is. But there is a problem. These servos only respond to positions from 0 to 180. We have seen the output from the joystick varies from 0 to 1023. We're going to have to write some maths routine that scales the massive 1023 down to 180 and all values in between. Luckily, once again, clever codes have come to the rescue and produced a scaling function for us. To scale x from 0 to 1023 down to 0 to 180, all we need to do is use the map function. Thus, you have control. In this video, we've learned how to connect and configure a servo. On the way, we've constructed an improved sketch template that includes constants, variables, and initial values. We also saw the power of using the include statement to adopt abilities that made it simple to drive a servo. We also used the map function.